Hi guys, this is Simon Expert. Today we prepared the following task for you. We have a ball of the given mass which is initially at rest and then it is released and falls downwards from the height 3 meters. It collides with the ground and bounces back to the height 2 meters. We know that collision takes place during this given period of time. And our task here is to find the momentum of the ball immediately before and after the collision, the impulse imparted to the ball, and the average force exerted by the ground on the ball. So, according to the law of conservation of energy, the energy of an object at the beginning of the trajectory is equal to the energy at the end of the trajectory. And in our case, this law is applied to both parts of the movement of the ball, for the downward movement and for the upward movement. Therefore, we will have two equations for the speed of the ball. The first one is mgh1 equals mv1 squared over 2. This is for the downward movement. And for the upward, we have mgh2 equals mv2 squared over 2. Now, from these two equations, we can find the speed of the ball v1 and v2 for the downward and upward directions. So, for the movement down, we have v1 equals the square root of 2 times g times h1, and this is equal to the square root of 2 times 9.8 times 3, and we get 7.67 meters per second. And for the upward direction, we have v2 equals the square root of 2 times g times h2, and equals the square root of 2 times 9.8 times 2, and gives us 6.26 meters per second. Now, as we know the speed of the ball for the downward and upward direction, we can find momentum of the ball for these two cases. So, the momentum P1 equals m times v1 and gives us 8 times 10 raised to the negative second power times 7.67, and we get 0.61 kilograms times meter per second. And P2 equals m times v2 and equals 8 times 10 raised to the negative second times 6.26, and gives us 0.5 kilograms times meter per second. So here we found momentum of the ball immediately before and after the collision. Alright guys, so here we found the momentum of the ball immediately before and after the collision. Now let's recall the definition of impulse. From its definition, impulse J is equal to F times delta T, or this is equal to M times delta V. And this is actually equal to the difference of two momentums, P1 minus P2. So knowing these two momentums, we can find the impulse imparted to the ball. So J is P1 minus P2, or 0.61 minus 0.5, and equals 0.11 kilograms times meter per second. And now from the same formula, we can find the average force exerted by the ground on the ball. So this is F, and F actually equals J over delta T. Or in our case, this is 0.11 divided by 5 times 10 raised to the negative 3. And this gives us 22 newtons. So here it is guys, we have the momentum of the ball immediately before and after the collision, the impulse imparted to the ball, and the average force exerted by the ground on the ball. Thanks for watching us, subscribe to our channel, see you next time. Bye.